Good morning to all the students. I am Shubhangi Gondane from Mechanical Engineering Department, and today we study about the microprocessor 8085. So what is the microprocessor? This is the diagram which is related to the inlet microprocessor core TM70. The microprocessor is an electronics instrument or component that is used by the computer to do the work. It is a central processing unit on a single integrated circuit chip containing the millions of very small components including the transistor, resistor and diode that work together. About 8085 microscope. An 8-bit microprocessor produced by the Intel induced in 1976 used a single positive 5-volt power supply by using a deflection mode transistor, use a multiplex address or data bus. So this is the diagram which is related to the Intel 805, and this is a 8085 microprocessor produced in 1975 to 1990s. This is a command manufacturer CPU having a 2.5 to 16 megahertz features, that is minimum feature size is 3 mm, instruction set is 80, transistor is 6500, processor is Intel 8080, successor is Intel 8086 and the package is 40 pins DPI. So this is the internal architecture of the 8085 microprocessor. So this is the main system, that is a that is a in charge control, and this is a serial input output. So these are attached with respect to the bus system, and accumulator temporary files can be attached with respect to the ALU. The flags can be reflected, and these inventory control can be attached to the cut ready, and these can be attached to the multiplex resistor, and all the data can be stored with respect to the address bus and data bus. So control unit generates signals with the MUP to carry out the instruction which has decoded really cause the certain connection between the blocks of MUP to be open or closed so that the data goes where it is required and ALU operates. Arithmetic logic unit, that the ALU performs the actual numerical and logical operation such as add, subtract, and or etc. Use the data for memory and from accumulator to performs the arithmetic. Always store the result in operation in accumulator. Register. The registers are used to quickly accept, store and transfer the data and instructions that are being used immediately by the CPU. There are various types of the register. Those are used in various purposes. General purpose register B, C, D, E, H, L. They have worked with the pair B, C, D, E, H, L to store the 16-bit data. One single accumulator, one flag register, two 16-bit register, the stack pointer that is known as an SP, and program counter that is known as an PC. Accumulator. This register is used to store a 8-bit data and to perform the arithmetic and logical operation. The result is stored in accumulator. The flags used to check the status of the result. They are called as an 0, carry, sign, party, auxiliary carry, flags, etc. The program counter PC. The microprocessor used that 16-bit register to sequence the execution of the instruction. This register is a memory point. The memory location have 16-bit address, that is why this is a 16-bit register. The function of the program counter is to point the memory address from which the next byte is to be fetched. Stack pointer. The stack pointer is also a 16-bit register used as a memory pointer. It points a memory location in RW memory called as a stack. The beginning of the stack is defined by loading the 16-bit address in a stack pointer. The instruction register or decoder. The temporary store of the current instruction of a program latest instruction sent here from the memory prior to execution. The decoder then takes the instruction and decoded or interpreted the instruction. The decoded instruction then pass to the next stage, the timing and control. The timing and control unit synchronize all the microprocessor operation with the clock and generates the control signal necessary for communication between the microprocessor and peripherals. The interrupts in 8085. The interrupt are the signal generated by the external device to request the microprocessor to perform a task. There are 5 interrupt signals, that is a trap, RST75, RST65, RST5.5 and NTR. The serial input output control. The 8085 microprocessor has 2 serial input output pins that are used to read write and 1 bit data to and from peripheral devices. The SID, that is a serial input data line, and SOD, that is a serial output data line. So some basic application of the microprocessor in general. There are a lot of application in microprocessor in general life. Some of the applications are mobile phones, data watches, washing machine, traffic control, modem, power station, television, CD player, multimeter and CRO. The block diagram of the camera with respect to the microprocessor. So this is the block diagram, shutter diagram, that is a lens can be converted to the image, analog data can be converted into digital signal and it can be stored with respect to the data bus. So this is a pin configuration which is related to the 8085. This is a 42 pins diagram of 8085 in which X1 and X2 are the input, serial input and output signal, that is a reset, SOD, SID, trap, RST 7.5, 6.5, RST, entered values data, address bus D6, 1, 2, 3, 4, 5, 6, this is a voltage, this is a hold signal, this is a RT, and these are the various types of the, so this is called as a pin configuration of 8085, and this is a diagram which is related to the microprocessor 8085 in a block diagram. This can be easily understood. This is a interrupt control system and serial control system. It is attached to the 8-bit internal data bus system. An internal data bus system can be connected to the accumulator, temporary register and flag. All this data can be contained with respect to the ALU. Then it is again connected to the instruction register connected to decoder, and decoder can be connected to the timing and control circuit. And these multiplexer register W, Z, B, C, D, E, SCL can be connected to the SP, PC, and the data can be stored with respect to the address buffer, that is the address bus, or data buffer, that is a data bus. So thank you.